Hi again. In this video I will be talking about the RC circuit, but this time I will be discussing the discharging capacitor process. Once again, all what I'm doing here is discussing some basic um, circuit analysis for the discharging process. So what we do here, I have this circuit as you can see where I have a fully charged capacitor with a resistor and a switch. Now, once again, the way I will be discussing the process based on mainly two time zones. Immediately after the switch is closed, which means t equals 0, and the second time zone will be after really long time. We kept this capacitor connected with the resistor for really some time. And the main elements or the main factors we discuss in these two time zones is the potential difference across the capacitor. What's going to happen to that? It's been fully charged, or the voltage was the maximum, or is the maximum. It's coming from just being charged, fully charged. The charge on the capacitor, what's going to happen over the time, and finally the current through the resistor. Is it going to be the same what happened during the charging process, or it's going to be different? And for this, we will use again our graphs to help us identifying or explaining the process for these two time zones and the elements. Now, as a start, I can choose the charging or the stored in the capacitor or the voltage across the capacitor, because what's happened here, it is happening on the other part. Now, at t equals 0, I will be starting with a fully charged capacitor. That means I am starting right from the top, the maximum value of the capacitor across the plates, or the potential difference. It's going to be same voltage like the battery. So I'm starting right from here, from the maximum, not like the charging process. After really some time, the capacitor will be used. We already used all the voltage across the capacitor plates. So when the time goes to infinity, or after really long time, no more voltage across the capacitor. The capacitor ran out of that voltage. So we are doing that gradually going down, which means it's the voltage across the capacitor during the discharging is decaying exponentially. It will drop quickly at the start, then gradually will keep dropping until it's vanished after really long time. Well, this is the same thing we can apply it for the charge. As a start, when t equals 0, I have a fully charged capacitor, which means Q will be the max, and it's going to be equal the full capacitance multiplied by the voltage across the capacitor. So you could use say VB, the battery voltage, or the capacitor voltage. And as I said, we're starting from the maximum value. We are coming from the highest amount of charges. As the discharging process happening, as the charges across that capacitor being used with that device, with the resistor, the amount of charges stored in the capacitor, it will vanish after some time. So there will be no more charges. That's it, done. And once again, that's mean the charges across the stored in the capacitor will be decaying until it goes like nothing. So after a really long time, there will be no charge stored in that capacitor during the discharging process. All right, let's go and discuss the current. Again, t equals 0. Now we said the current through a resistor will always flow instantly as soon as you close the switch. So as soon as I close this switch here, done, the current will flow through this resistor as a maximum value. So once again, I will be starting with the current. Just like the charging process, the current will be starting from the maximum value. of that current. But as the time goes, when I reach infinity, well, the source of the charges creating this current, or the potential difference creating this current during this circuit, is our capacitor. So this fully charged capacitor is the source of this current. But as we said before here in these two topic graphs, as the time goes, the potential difference across the capacitor is decaying, and the charges is decaying. That means the current as well will be decaying gradually until it vanish. So the current through the resistor will be also vanishing until it goes to 0. So here you can see the three graphs for the time, the two time zones, 0 and infinity. What is happening to our potential difference across the capacitor, the charges stored in a capacitor, and the current going through a resistor, while I have an RC circuit in a discharging process. Everything is decaying. We start from the maximum values, and as the time goes, that value or that item will vanish, will go to 0, which means we need to start the process again of recharging the capacitor. So let's summarize everything. Here it is again. When the time is 0, the time is infinity. The voltage across the capacitor will be the maximum when it's time 0. The charges means also the maximum, and the current will be the maximum at that moment. After a really long time, we said everything will be vanishing or decaying, so they will all goes to 0. Now, if I want to study the voltage across the capacitor, the drop of the capacitor voltage, or the loss of the charges stored in the capacitor, or how is the current going down through the resistor as a function of time during this discharging process, I will be using these three formulas. Depends on what it's being asked. Is it the voltage for the capacitor, the charge, or the current? Okay, so this is all about the discharging process of a capacitor in an RC circuit. I hope you find this video useful. In the coming videos, I will be trying to solve examples about charging or discharging a capacitor in an RC circuit with different elements and different items. Thank you.